यूनिट 4 जिसमें है MCS-207 का यूनिट 4. ओके, ब्लॉक 1 के अंदर में यूनिट 4 है. ठीक है, 4 यूनिट्स है फॉर ईच ब्लॉक. सो फाइल ऑर्गेनाइजेशन इन DBMS सिंपल एक्सप्लेनेशन इसको देख लेते हैं. डेटाबेस स्टोर्स डेटा इन टेबल, राइट? But large databases are stored on secondary memory like HDD or SDD. How data is stored and access affects performance. So देखते हैं. Storing table as files. Each table can be stored as a separate file. Each table as to file. Each table can be stored as a separate file. Related tables can be stored together in the cluster file. Example: employee table, employee.txt, department.txt. So storing tables as a files, these like extension with txt kind of that. Attribute storage. Attributes of the record row can be stored together, like employee record has id, name, salary stored together as one record. Okay, employee record has id, name, salary stored together in the one record. Ordering of records. Records can be stored in any other disk, but ordering can improve retrieval. Access methods. Sequential access, read record one by one. Direct or random access, retrieve a record directly using key. Or extended access, use a index is quickly locate records. Column oriented storage. Advanced है store all employee salaries in one block. Summary. File organization, how table is stored in the disk. Access method, how data is retrieved effectively. Proper organization improve performance of large database. Physical database design. Okay, convert logical design tables ER diagram into technical storage of DBMS. Insurance ensure performance, integrity, security and recoverability. Physical database. Convert logical data design into technical storage of a DBMS. Input needed. Normalize tables. Attribute definition, how data is used. Insert, delete and update, retrieve. ठीक है. Decisions in physical design. Choose optimal data types. Adjust logical design if needed. Decide the file organization. Physical records stored in the secondary storage. Attributes is minute. Physical file design issue. Physical records. Attribute design consideration and decisions in physical design. Input needed. ठीक है, ये है कुछ. Database storage in HDD or SSD. Simple explanation. File organization versus access method. File organization, how data records and arranged in block or disk. Access method, how data is retrieved based on the arrangement. Why use HDD and SSD. Databases are large, cannot fit entirely in RAM. Secondary storage is permanent and cheaper than main memory. Disk storage basics. HDD makes the shipping platters with magnetic layers. Data stored blocks and pages. CPU request a block, reads into buffer cache. SSD use flash memory, no moving parts, faster access and lower latency. Record storage, fixed length records. Each attribute use fixed bytes, variable length. Attributes like var, null, etc. And file organizes database. Simple explanation again. So file organization, how record of a file arranged in a secondary storage. And a good file organization balance fast data access, efficient storage. Selection factor, how often data is accessed and updated. Role of DBA chooses the best file organization for each table, uses splitter. Unordered heap file organization. Records are stored randomly with no specific order. Supports insert, retrieve, and delete operation. Key features: new records are added into available space. Sequential file organization. Records are stored in the order of priority key best sequential access. Records are arranged by key values. Works well for tasks where most of the records are accessed. Advantages: efficiency for batch processing, good for sequential access. Disadvantages: random access is slow. Update, insertion, deletion require rearranging of new file creation. Index sequential. Okay. Index key address. Records are stored sequentially by primary key, but an index is maintained like a dictionary. Advantages: faster search using index, good for both sequential and random access. Easier insertion deletion with overflow blocks. Hash file organization uses a hash function to calculate where a record will be stored. Hash function converts a key into a block address. इसका advantages: very fast for equally search, efficient for insertion and retrieval using the hash key. Disadvantages: complex to maintain, range search buckets. Okay, indexes in DBMS. Indexes like the index all end of the book format helps to find data quickly without searching any records. Type of indexes: primary indexes built on ordering field like primary key, one entity per block. Example: student DB, order, enrollment number. Advantages: fewer block access. Disadvantages: clustering index built non-key attribute. Multiple records can point to one index entity. Secondary index में अगर तो built in non-ordering field can have many secondary indexes. Now index on student name when searching on fields other than ordering field. ठीक. Implementing index using tree structure. Binary search tree BST. B tree. Special trees used for large index. Store sparsely on disk. Properties of B trees: each node can have n by 2 and children can store and one key in node. Real life we used to think of dictionary where each word points to the page. If dictionary is small, you can keep it memory and find quickly. B tree. Think of library catalog system where millions of books indexed by ID. Multi-file organization. Normal file one key, but in real life we often need to search the different keys like name, branch, and this. Why do we need multiple access paths? Bank example: teller, loan officer, branch manager. Multi-key file or normal file. A normal file have one, but in real life we often search different keys. Why do we need multiple access path? Teller: search by a branch code plus account number. Search by loan limit. Search by account type. Technique: multi-line organization. Use multi-list access. Each access points to the link in stored order. Real life example: one index is by gender, another by course. Importance of file organization in database. Efficient data access. File organization decide how records are stored and accessed. The right method makes searching, insertion, deletion, and updating records. Reduce processing time. A proper file organization reduces the time taken. Example: using a hash file for searching by account number is faster than searching all records. Optimize disk uses. Record organization avoids unnecessary disk access and saving storage and reducing hardware stress. In short, file organization is important because it directly affects space efficiently and particularly of database operations. Choosing the right ensures fast queries, better storage use, and smooth application performance. Efficient data access, reduce processing time, optimize disk usage, supports application needs, avoid performance problem. Okay, so these are the important of file organization in database. Multi-file, why do we need? Bank example देखेंगे. Technique, multi-fast organization. Imagine a school database with student. One index is by gender, another by course, something. ठीक है, तो यूनिट 4 is all about file organization in DBMS. ठीक है.